Hello, my name is Zach Semke, Director of the Passive House Accelerator, and I'm happy to introduce our session, OutPHit, the strategy that's scaling up retrofits. OutPHit is a program developed by PHI to empower the acceleration of large-scale renovations while maintaining EnerPHit quality. Today, our presenters include Jan Steiger, head of the tool developments team at the Passive House Institute, Berthold Kaufmann, senior scientist, also at the Passive House Institute, Nuria Diaz Antón of VAND Arquitectura, and Etienne Vekemans of ProPassif with Roman Claret of Plan 9. Don't forget to ask questions in the chat, and after the presentation, we'll have a panel discussion. So let's get started.
Hello, everyone. Greetings from Darmstadt. This is Jan Steiger speaking for the Passive House Institute. As you may know, we are coordinating the EU-funded project OutPHit. And today I'm talking about the strategy that's scaling up retrofits. We are happy that we can also present here at the Passive House Network Conference. And my colleagues will be presenting about three multi-residential building renovations in Spain, in Germany, and in France. Looking forward to hear them. But now let's get an overview over OutPHit. As you may know, OutPHit wants to make deep retrofits faster, cheaper, and more reliable. And doing that, we're trying to pair prefabrication or streamlined processes with the rigor of the EnerPHit standard, making sure that the buildings at the end of the day perform as intended. In order to demonstrate that this is possible, we had engaged in quite many case study projects. 10 were intended initially, but we were able to, involve more, as you can see here. Lots of projects in 6 or 7 European countries of different types, residential buildings, but also non-residential buildings, small single-family houses, 3-family apartment buildings, but also bigger buildings, a hotel, a university, quite a variety, as you can see here. And as work with projects works, those of you who are architects or engineers know it. It's not always straightforward. We had Corona, we had increased prices in the construction sector in the meantime. So many of those projects were actually canceled, unfortunately. 9 of them, as you can see here. But we are happy to tell you that 9 of them have also already been completed, and more will be completed in the near future. 4 on site still, and 5 are somewhat delayed. Some in design stage to be started later on this year or early next year. So let's hope that there's more interesting findings to be gathered. Those case study projects, they are the backbone of the whole OutPHit project. We want to extract findings, monitoring results. We also want to set up tools and test them during the case study projects, and of course, receive materials like pictures, information, detailed drawings, and whatever to disseminate or involve stakeholders to tell them that this works and how it works. Some of the activities, for instance, were the tools where we, in this case, had a look at the embodied energy, or let's be more precise, the manufacturing energy, so the energy that has to be invested to produce the materials. We have developed this tool, and using these tools, we come to some interesting results. For instance, for this renovation project, unfortunately, it's been cancelled. But anyways, this one is in Hamburg with a brick cladding, and it was intended to have a brick wall cladding again after the renovation, not unlikely, for instance, as in New York. And here you can see that the discussion about how much insulation will be invested into the building, of course, leads to the statement or the finding that if you go for the EnerPHit standard, you have to invest a little bit more energy into the whole building. Glazing is more or less the same, or windows, but the investment into the insulation is slightly higher. But if you look at the totals, compare it to the operational energy that has to be invested into the building in the next 40 years or so, then you can see that, first of all, of course, it's worth it to insulate or renovate. There's a reduction to the standard renovation anyway, and the reduction is even higher if you go for the EnerPHit standard. The upfront investment into the manufacturing energy, as you can see here, that's these orange little squares, cubes, or whatever you call them. That's so small that it's hardly relevant compared to the operational energy that will still be there even after the renovation. So the reduction in the consumption, the reduction of the operational energy is the way more relevant thing to optimize. And even if you look at the manufacturing energy, the embedded energy in the components, in the materials, if we look at the walls only, in this case, it was this brick wall. And here you can see that the difference between the standard renovation on the left side and the EnerPHit renovation on the right side of the graph here, that's not so big. What is more relevant is the optimization of the brick cladding itself. Better go for brick veneer, thereby save a considerably more upfront manufacturing energy. It's not the light insulation material that ruins here this balance. It's the brick which contains so much energy. So this tool will help you to carry out some of these considerations and get a better overview, and then be able to discuss with your clients or whomever about the situation. Furthermore, of course, there's more and more systems being offered also for renovation, not construction systems, but renovation systems. And these we want to quality assure, like we have been doing with the construction systems or windows or ventilation. So we're going for certified components to provide assurance for building owners, housing companies, municipalities, or funding institutions that these fast and cost-efficient renovation systems, which are being offered by several providers already, that they are reliable, that at the end of the day, they will perform according to what they claim to be able to do. And of course, it's also a facilitation for any engineer, designer, or other professionals, and also certifiers or auditors, if there is approved specific values of these systems, so you can use them in design or calculation. That is the aim of this whole house renovation system certification, which we're working on. And in order to do so, we have been working on criteria and requirements. The criteria will be orientated at the whole house considerations. So we're looking at roof, wall, floor slabs, windows, and ventilation as a kind of a complete renovation package that is needed for a building to make it a deep retrofit. And then there are some obligatory descriptions to make it fail-safe, like an airtightness concept that needs to be described, a user manual, and inhabitant introduction needs to be provided. We need an external shading concept that is part of every of the buildings that needs to be provided. And then there's some additional optional features, like, for instance, quality assurance, maintenance services, or whatever that can also be part of this renovation package. Working on this criteria currently, we have set up this table, which kind of puts together all the individual components, like for construction systems, so the building envelope, the opaque building envelope, the windows, and the ventilation. Of course, allowing this certification on an international basis, so orientated to the climate zones of the Passive House Institute. And last but not least, we have been developing this monitoring concept. You may have heard of it, a complete package with defined components for a minimal monitoring, also defined data and data formats that have to be transferred to our database, and finally a comparison of the energy design and the consumption. Let's have a look at it. The equipment consists of a weather station, some data loggers, a transfer unit that transfers, that receives the monitoring data from the logger and then transfers these to our database. The costs, the estimated costs for a single family house, for instance, are around 1,500 euros. Costs for a 12 apartment multi-family residential, are about 7,000 or 8,000 euros. These would be implemented in a building, and then the monitoring can be run for 1, 2, or more years to make sure that we've at the end of the day, that the renovation or the new build project fulfills its expectations. As you can see here, we'll have readings of, for instance, the room temperature, the indoor humidity, or the CO2 levels, so we can assess the comfort and, of course, have indicators if the building, the whole comfort in the building, like temperatures or humidity, is according to the expectations. And finally, of course, we also want to know if the consumption is according to the energy efficiency design. So this comparison will be done with the monitoring readings and the energy balance calculation, which is running on the server and which will compare if, well, the consumption is within the range of expected performance. So we want to know exactly if the buildings perform according to their design. This is it for the time being. Thank you very much for your attention. These are the partners of OutPHit. Should you have further questions, please contact me. Here's my email address or the homepage of OutPHit. Please contact me should you have questions, and otherwise, please pay close attention to what our colleagues now have to tell you. Thank you very much.
Hi, everybody. Thank you very much for the invitation to speak at the Passive House Network Conference this year in Denver. I would like to speak about serial renovation of buildings with prefab elements. This work was financed and done within the OutPHit project. I will show you in some detail later. Well, to start, I would like to define the EnerPHit standard, which it describes reasonable energetic renovation actions for buildings towards Passive House standard. Well, and then the point is, what is special with prefab elements? And there I would like to go in some questions, and this is mainly about thermal bridging and air tightness. Well, the EnerPHit standard is the idea behind this is to use passive house components as you know it from new build passive houses as well for renovating of buildings. So thermal insulation of wall and roof 0.15, thermal insulation of windows 0.85. Please use repaint glazing, minimize thermal bridge effects, do the air tightness as good as possible, and use ventilation with heat recovery with a very well heat recovery number. Well, and as we know that heating to deal with old buildings, renovation with old building is somehow more tricky than new build. We said, well, let's do the limit values a little bit higher than for new builds, and so the heating energy demand for renovated buildings is about 25 kilowatt hours per square meter instead of 15. And alternatively, we allow you to go for the most economic quality of components as you can do it the best. Okay, so what about prefab elements? The idea behind this is if you have many buildings or maybe large buildings with large facade areas and roof areas, you may use the similar detailed planning for more than one buildings and for more than one building and for larger areas. So do what you have learned once more times and so make it more rational. Yeah, we prefer wooden construction for these elements, but well, as you know, you can use any other materials if it is as good as possible without thermal bridging. So here you see a prefabricated element in front of a facade of a renovated building, here including the windows. The U value of the new wall is about 0.13. The elements are in this case filled with cellulose, but you can use mineral wool as well. The old balconies had to remain there because the the landlord said they would try to bother all the tenants not more than needed. Yeah, and therefore they let many things just as were in the old building. Okay, here you see the construction, the detailed construction of the outside elements. Here the old wall, which had already 8 centimeter of EPS layer, and on top of that there came a mineral wool layer, and then the element with a rigid layer and outside a cladding facade. Yeah? And the filling is with mineral wool and cellulose, both together. Well, and the U value overall for this example is 0.125 watt per square meter Kelvin. Well, these elements are quite large and therefore heavy, and therefore you have to provide good anchors, stable anchors, and these anchors produce a large thermal bridge effects. This is not a problem as these are not so many anchors, but you have to account for this thermal bridge effect so that you can account it in PHP. Here on the left-hand side, you see the anchors in a picture, and on the right-hand side, you see these anchors in the drawing. Okay, here you see the roof element is fitting perfectly to the wall element, and therefore all around the building, the new shell is quite well and fitting everywhere quite well. But as you know, the detailed design is crucial, and therefore I would like to emphasize a little bit more about airtight connection of these elements and how to process this at the mounting. Well, and one idea to do so is use some 2 rubber tubes in between of the 2 elements. And as you bring them there, the 2 elements, and bring them together, the 2 rubber tubes are just squeezed in between and do it very well airtight. Yeah, and as you can see here, the 2 rubber tubes are then just between 2 elements, and you have a perfect airtightness. Another point is the stability of the prefab element has to be better than for normal element by element or the normal outside construction, thermal layer construction, and therefore the wooden fraction is a little bit higher than for normal insulation layers, even if you do it with wooden beams. Well, so please care about the wooden fraction and check if there is much wood. The thermal bridge effects would be a little bit higher, and you have to account for in PHP. Please be careful. Well, another point is fire engineering. This is a little bit tricky as you have to be very careful. Yeah. On that example, you see the facade has to be separated by non-flammable material so that in case of fire, the fire cannot overlap from one level to the other. And this comes here with some steel layer between each element at each ceiling from floor to floor. Yeah. Well, and the solution in that case was done like this. So they had a metal membrane all through the facade from inside to the outside, and this has the here on the right hand side where they did it, and this has 2 reasons. The point is they had to stick for the standard solution according to the German norm, standard fire engineering, because they had not the time to ask for a special allowance. they could have done it, but they had not time to do it. And the other point was they wanted to have a non-interrupted outside cladding. And therefore, the fire engineer said, well, you have to do it like this, and there's no interruption allowed for this metal film here. On the right-hand side on this picture, you see they did a interruption of the cladding, and therefore the steel element was only this short L and nothing else. As you look here, they had to separate the existing EPS layer, which was already there on the wall. They had to separate it at each floor ceiling by a mineral wool fire bar, so that it was to get it safe. Yeah. So the general thing is, please do it as good as, please discuss the fire engineering issues very careful with the fire engineers so that it works good. Okay, another point is the windows. Best case, they should come together with the facade elements in one piece. Well, and as you can see here, the old window is demolished and the new window is moving out to the thermal insulation layer, as we recommended for new build passive houses as well. So this here is perfect. Well, but then you have to care about the reveal where the old window was located. Here on the right hand side, you see here is on the second from right, you see the window, the old window yet, and the new window in the element is on the outside, and in between everything is open so far. Yeah, and you see here on the utmost right picture, you see there is an open part of the old masonry wall, and this has to be closed very well airtight. Yeah, and you see here on the third picture from right, you see here the airtightness was done very well, and on the left picture you see all the finish. Yeah, so they did it quite well, but please, this is really crucial. And we did preliminary blower door testing with these windows, and we saw, well, it's quite okay. Yeah, so good solution so far. Well, in principle, you should go for larger windows for balconies and so the same way. So do it best on the right hand side here. The window is in the insulation layer. But well, here, as you see in this picture in the middle, sometimes this is not possible. And so they had the new window at the same position as the old window. This is a compromise with respect to psi values and position of the window. Well, and the second compromise is the quite thin thermal insulation of this niche of the balcony. Well, and I already said the slab of the balconies was remained there, and they wanted to have it like this, not to bother the tenants more than necessary. Yeah, so this is a compromise, but we checked it is from the energy balance, is it so just acceptable? Yeah. Okay. Last thing, when we come with prefabricated elements, we could go for extra elements which carry all the building service stuff. Yeah, here in this kind of a backpacker outside of the old wall, here in between the other wall elements, on the right picture, the ventilation system and the connecting to the district heating. This is located here in this backpacker, and so you need no room for this inside the apartment. Yeah, so it's just a good solution to do it like this. Well, and here you see a slightly different solution. They had their ventilation system installed on the balconies, and the and the piping for the ventilation system is partly included in the wall element you see here, and therefore they had to move out the window a little bit further to the outside. But doing so, you see it here in the middle picture, the supply air valve is just positioned right nearby the window, on top of the window. Here you have the horizontal cross section of the window with the air outlet coming directly from top. Well, here you see the already installed facade elements on some of the buildings in the construction site in Germany. The roof level is yet there. It will be removed later, and there will added some an additional roof level, so an additional apartment, which then will be absolutely free of thermal breaches, as it is new build. Well, and then they have a very high performing building ready for use for many further years. Well, and this is my input for today and for this conference. I wish you a good discussion and good input, and bye bye so far.
Hello, everybody. My name is Nuria Diaz Antón. I'm architect and passive house certifier from Band Arquitectura in Spain. In this presentation, I would like to show you one of our case studies from OutPHit. This is the project of a multi-family building renovation in the city center of Madrid. Here you can see some pictures of the building. It's located, as I already said, in the city center of Madrid. Madrid has a warm temperate climate and almost 700 meters above sea level. Our climate is continental with cold winters and very hot summers. And it's also very important in this case, and also when we are working in the city center, to take into account the effect of the urban heat for summer comfort testing. It's very important because we can maybe have 2 or 3 degrees more in the city center than in the outside of the city. You can see here one picture and some plans of the original building. It was an office building built in 1972 using a traditional construction system, concrete structure, brick facade, flat roof without any insulation at all, and a window frame made of aluminum with double glazing. We didn't make any energy calculations of this existing building, and we don't have a lot of information about it because it was unoccupied for several years. It is also important to think that this building has changed its use. So it was in the original situation, it was an office building, and now it is an housing building. From the beginning of the project, we start working with the architects. We made the design PH, as you can see here in these 2 pictures. This picture shows that we have a lot of high buildings in the surroundings, which provide our windows with a lot of shadow. And if you think about the orientation of the building, this is not optimal because this is the north facade and this is the west facade. So we can't use the south facade to get this solar gains so important for our projects or our passive house projects. This south facade, we can use it only for lighting and ventilation of the common areas of the building. Here you can see the PHPP verification sheet after the retrofit. You can see that how we meet the EnerPHit standard through the energy demand method. Although this orientation of the building was not ideal, the limit of the heating demand in our warm temperate climate is 20 kilowatts hour per square meter and year. So we use or we improve our components till this 20. It was very important to work from the beginning in the construction details of the building, because in this kind of retrofits, sometimes you can't use standard solutions. So we need to analyze every single detail and to look for for the better solution for each one. One of our tasks in the OutPHit project is to develop a construction detail catalog that you will find very soon in the website of the project. We also, from the beginning of the project, we worked with Flixo to calculate the C values and temperature factor of all of these details. Now we are going to see some nice pictures of the construction works. First, this thermal envelope and insulation layer. Here you can see on your right side how we develop the thermal envelope. The common areas are outside this thermal envelope in this case, because it was very difficult for us to work with the elevators and some of the issues of these common areas. The main facades, the north and west to the main streets, we installed a ventilated facade, and in courtyard we work with ethics as it is a little bit cheaper. Here you can see the airtightness concept. We made the airtightness of each of the apartments individually. We used for this airtightness some existing materials. That was one of the challenges of this project, because sometimes we couldn't ensure from the beginning that this material was good enough as airtightness. So we needed to do a lot of blower door tests during the construction works. And also, as you can see in the picture below, for some special points, we need different solutions. In this case, we didn't have a lot of space to make a brick wall and then a plaster airtight layer for this place, where it's only for the facilities and pipes. And we did this solution with OSB. The ventilation unit was is suspended in ceiling in the suspended ceiling in bathrooms, as you can see in the picture. We use a decentralized air ventilation system. That means that we have one ventilation unit per apartment. This is very typical in Spain. That is not common to find centralized solutions. Everyone wants his own ventilation unit and his own heat pump. This is not optimal sometimes for the budget and for the efficiency. and we are always working to change it. But at the moment, is something that is demand in the market. So we did it this way in this building. Here you can see some nice pictures and also a drawing of the window installation. We worked with passive house windows, and as I explained you before, we need to do a lot of blower door tests. As we are using existing materials for the airtightness layer, we need to test if all of these materials are working and I think we did at least three blower door per apartment. So 2 during the construction works and the last and final test. In this picture, you can see the heat pumps for heating, cooling, and hot water production. The distribution of the heating and cooling are done with this underfloor heating system. And the owner of the building wanted also to install an additional fan coil in all the rooms west orientated. As I explained before, the west orientation in Madrid can be very, very hot in summer. And as this is not luxury but high quality apartments, the owner didn't want to install only this underfloor heating system. According to our calculations with PHPP, this additional fan coil is not necessary at all. So let's see in the monitoring what happened. We installed some photovoltaic panels on the roof of the building. As we don't have a lot of space, this photovoltaic system is designed only to cover the electricity demand of the common areas of the building. So it's not for the electricity of the apartments, but for the common areas demand. And one of the most interesting things of this project is that we started 2 months ago a complete monitoring, comfort, temperature, humidity, air quality, and also electricity consumes of the whole building. This monitoring, we are doing this monitoring within the OutPHit project, and after the summer will be available the first results. So I invite you all to come to the website of OutPHit project and to follow our updates, because we are working for to show you these results in the next months. The renovation challenges here in Spain is that we have to the next years we have to renovate a lot of buildings. I think as in a lot of other cities in the world, and we have some subsidies. It's quite interesting, but we don't have solutions, prefabricated solutions available in the market at the moment, or in case we have some of them, the cost is very high. So we are working from OutPHit to demonstrate how important is to improve processes in retrofit works in order to meet our global goal of renovating all of our buildings to EnerPHit, or at least to high efficiency buildings. And I think this is everything from my side. More information of this project are available in the webpage of OutPHit. Thank you very much for attending, and I wait for your comments and questions on the chat.
Hello, my name is Etienne Vekemans, and I'm working for Propassif here in Paris, and I'm pretty much excited to welcome you to this OutPHit workshop dedicated to the case study 38, which is the college GMP from the University of Lorraine on the island of Saucy, nearby Metz. I will present this case study with my partner and friend, Romain Carré, who is the fluid engineer on the project and who will present to you the consumption more in detail. As you know by now, OutPHit is dedicated to cheaper, faster, and more efficient renovation through the use of prefabricated panels in order to over-insulate the roof, the facade, and the basement of the building of the existing building stock. We, by Propassif, coordinate the case studies in France within the OutPHit consortium. France is one of the 7 realization countries, such as the Netherlands, Austria, Germany, Spain, Greece, and Bulgaria. We, in France, concentrate on the use of prefabricated panels through 4 case studies. The first one is case study number 7 in the Pyrenees, it's called Adorable Bagnères, in the city of Bagnères de Bigorre. The second one is case study number 9, is Agena in Lons-le-Saunier, which has been certified EnerPHit a few days ago, and it's I think one of the first certified buildings within the OutPHit project. The third one is the case study number 29. It's a school called Paul-Éluard in Bonneuil-sur-Marne, which is in a suburb of Paris. And last but not least, one of the last projects of OutPHit, case study number 38, which is the college GMP of the University of Lorraine on the island of Saucy, nearby Metz. Here you've got an overview of the different case studies in different countries, and we want to concentrate on the college GMP, which stands for Génie Mécanique et Productique, and you see on the right side of the slide the facade of this college. Well, the college GMP on the island of Saucy, nearby Metz, is a very standard building of the 70s, made of reinforced concrete with no insulation, and the fact that it has a heat consumption of 350 megawatt hours per annum was the main reason why the University of Lorraine wanted it to be thermally renovated, and the idea is to reach a division by 6 of the heat consumption of the building after the renovation. Well, why the heat consumption of gas is a huge concern for the University of Lorraine is because of the Ukrainian war in Europe. The megawatt hours of gas fluctuates between 50 euro to 300 euro, and as such, it's a major concern for an institution such as a university. you may also see that it has the collagen has been heavily used in the last few years. So there's also quite a huge need for renovation of the building. The idea is to keep the general overview of the building, and you see here that the prefabricated caisson, we call the mode nature architecture of the original building, and it's 2,700 square meter. And the prefabricated caisson deals with the whole techniques problematics of such a renovation, which is to bring over insulation, to bring also better insulated windows, to deal with the thermal bridges problematics, and to also to achieve a huge air tightness of the building after the renovation, in order to integrate the ventilation with heat recovery. This is one of the experience we made within OutPHit. It's better to have a restricted pools of experts in order to reach the aim of this retrofit, which is to achieve EnerPHit level. And so the University of Lorraine built up a team around the architect Plan Libre, the structural engineering office Perrin and Associés, the fluid engineering office Plan 9, and with the manufacturer of the boxes, which is the company Hansinger. Here you've got an overview of the site. The site is on the island of Saucy, in the middle of Metz, and you see this huge motorway crossing the site, which makes the acoustic dimension a huge dimension for the renovation also. The 2,700 square meter are divided on 4 levels, and the idea is to renovate those 4 levels with the use of prefabricated caisson. So you see here on the left the facade before renovation, and on the right of the slide you see the view after the caisson will be installed on the building. And now I give the floor to Mr. Romain Claret, who will explain to you more in detail the technical conception of those prefabricated caissons. Thanks a lot for listening, and have a great day.
Thank you, Etienne. I am Romain Claret from Plant-Neuf in Nancy, France. I present you a technical element of the Saucy project. So on this slide, you can show the significant reduction in the proportion of glazing between the existing here and the project here. This reduction in glazed surface is important because it helps us to avoid overheating during the summer. So, in the next slide, I show you the principle of insulated facade module. You are watching here a 3 level on our example. The lifting equipment is essential to the operation, and perfect coordination between the teams is required to prepare the onshore here and receive the elements. So in the concept of the detail of the wall, we can see on this slide the original wall here and the new elements which are added here. So you can see the position of the window in the new wall here, which is put on the limit of the actual wall. It's also this position is also a balance between thermal performance and easy use of the system, because distance between the interior wall here and the opening system must be reduced to the minimum to maintain a sufficient maneuverability for people with reduced mobility or for children. You can see also supply and extract units and ventilation ducts here integrated in casing. And after interior part here and the exterior parts are carried out at a later date, because these elements are fragile for transport and can't be prepared in advance. Here I show you the thermal performance of the wall. We can see the impact on performance of installing the framework and the ducting compared with a case without. We have a reduction of nearly 30% to obtain a wall of about 0.18 watt per square meter Kelvin. We can also increase a little bit the size of the wall to reduce the U value to 0.15. Of course, we try to work to a maximum with biosourced material. So the box consisting mainly of wood for the framework and cellulose weighting inside here. We complete the complex with rock wool here and glass wool, which are used for fire resistance. And you can see also the air elements. When the wall is positioned on site, we put a ventilation unit on the roof of the building with fresh air pipes and exhaust air pipes, which are collated from the facade on the top of the wall, and through a ventilation room is created and installed to facilitate equipment maintenance, and the access is from inside the top floor. Okay, so I present you, according to PHPP, the results of the calculation, and you can compare before and after retrofit. So we have a reduction of 5 times the level of consumption, which is nearly 130 kilowatt per square meter before renovation, and we obtain less than 25 kilowatt after retrofit. So the level is conform to EnerPHit level. So in this slide, we compare the cost and the emission of carbon dioxide. The reduction of carbon is nearly 5 to 6 times, and the cost is 2.2 million euro of investment. So if I compare this for 50 years to 100 years, the economy of carbon vary from 3,700 tons of carbon to 7,200 tons. And when I divide the price by the economy in carbon, I can obtain the price of the carbon ton, which fluctuate from in our case from 300 to 600 euro per ton to be profitable.
Well, that was amazing. And Ramon, what a way to close up as well with those numbers about the payback. And I think that all of us are really eager to dive into, I think, the questions of cost and you know, the how we can all deliver on this promise of deep energy retrofits becoming faster, cheaper, and more reliable, as Jan mentioned at the top of the program. So, but before I do, I just want to express how incredible this project is, this effort is, and I think how grateful on behalf of our Passive House community here in North America, how grateful we all are that you're doing this work, because we all know like how incredibly vital it is for us to figure out how to deal with our existing buildings and how to do that quickly. We all feel a sense of urgency, both in terms of mitigating climate change, but also adapting to climate change and making places where we can thrive and be resilient. So let me just dive into a little bit into this cost question as maybe a way of teeing it off, since Ramon, you kind of teed us up so well. And so I'm specifically referring to Ramon's data that suggesting that the break-even point over 50 years for the retrofit would require a price of carbon set at 600 euros per ton, and the break-even over 100 years would require a price of carbon set at 300 euros per ton, and which is a kind of one way to look at this, right? The price of carbon now is 83 euros per ton, and it hit a record of just over 100 euros a ton in February 2023. So clearly by this analysis, we have some work to do ahead of us. But so I'd like to explore this question of cost a little bit. One thing that also another way to frame this question, I've had some good conversation with James Gepner of Retrofit New York, and from at NYSERDA, and the way that he's grappling with how to make industrialized retrofits pencil, and the way that he has been framing the economic feasibility question is that you have a combination of two things that we need to understand in terms of what the cost point is that we need to get below in order to make this stuff take off in the marketplace. So, and it's a combination of the money that's on the table already. So that's the money that it will take to renovate an old, kind of drafty, obsolete building to just be kind of up to snuff, to be able to still attract tenants and residents. That's kind of the money on the table, a basic renovation. So that's one part of the money pot that is potentially available. The other part is the valuation of the passive house benefits, that the market kind of the value that the market recognizes of the passive house benefits. So, and that can be partly energy savings, but also like the health benefits of better indoor air quality, the comfort benefits, lower maintenance costs, lower vacancy rates, passive survivability, the lack of the need to displace residents when this work is happening. All those have value. Now, it's an open question how much the market will recognize that value. But I think that as we've been experiencing heat domes and power outages and wildfire smoke events, that there's reason to believe that the market will be better at kind of valuing those benefits than maybe the market would have done 5 years ago. So when you put that money on the table for a basic renovation of a building just to be able to keep on renting it, for example, plus the passive house benefits, you get a number. So say theoretically that number is $80,000 or 80,000 euros per unit. So this analysis is suggesting that you have to think about that number and beat it if you want it to, you want this thing to scale. So that's a lot of talking for me. So I promise I won't do that anymore, but I just want to kind of frame this conversation a little bit around cost, and then and recognize that this is like the very early days of this. So of course it's going to be expensive. We want to drive the cost down. So maybe starting with Jan and Berthold, what pathways do you see for reducing cost? And are you targeting a certain kind of general cost point per unit that you think is the sweet spot that we need to get below? How are you thinking about this, and where do you see this moving in the future?
Well, so far the costs for serial renovation are not lower than for the normal approach, and so I think the learning curve will be longer than estimated before. Yeah. Mm-hmm. So some things are promising, but others is as we see what some mistakes happened. I just they happened. Well, you see, you have to do a better and more thorough planning in advance. Otherwise, you will fail. If you will have the good planning available, you can do a repetition faster and therefore cheaper. Yeah, but to start this and to start the repetition, you have to finalize your planning, and it has to be more effort to do that. And this is, by the way, what Mary James asked here: how do you convince manufacturers to go for it? Well, so far there are not so many manufacturers coming there. Most of them, they are going with new build, and so there is some experience. But for the renovation, the challenges are a little bit more, and therefore, sorry, we are not at the end of the development. We are just starting.
Right. Yeah.
Well, so far from my side.
Yeah. Great. Thank you, Jan.
Well, by the way, just one. Lisa Mann asked, no relocation of inhabitants. This is another goal, and I think it's very promising. But the same is true for the construction site, what we have seen so far, and not only on one project. If you do not manage the process of the on construction site, you will bother many people. And therefore, it's not only the serial, which might be a little bit faster, but it's the process on site, which you have to organize very, very well. Otherwise, there will be no advantage to the standard renovation without people there. No. Okay, sorry.
No, got it. That's great. Thank you.
Yeah, I might add what we have seen in the last 3 years, that of course everyone is aiming for industrialization of the whole process. All those providers do want to sell a product, but in the end of the day, buildings are that individual that it paid off to have someone competent, a designer, an expert, who takes care of all the very tricky connections or thermal bridges or whatever. And I think this is something where the market should reconsider to at least have those experts involved in their companies and not just sell like they sell cars or whatever. It's not something which you can sell over shelf. It's a building, and this is one of the things we think where the quality assurance will pay off in the end of the day. Because as you mentioned, I mean, the health benefits and everything, they only occur when the building is put up right and well, airtightness is okay and thermal bridges are eliminated and everything.
Right. Yeah. I mean, that, and
2 cents.
Yeah, thank you. And it is such a kind of important contribution that OutPHit is bringing to this the overall conversation. It's like, yes, industrialized retrofits, and let's make sure we're doing them right. And this is how we can bring some rigor to ensuring that that's the case. And I think the certified components piece is really exciting to see develop. And so yeah, really important leadership. So Nuria and Etienne and Roman, I just dwelling a little bit on the cost thing. I think both of for both the projects, it was I think there's probably some learnings there. Were there certain areas that you see that from your perspective, you see the potential for the most kind of cost containment, or the most opportunity to bring costs down in OutPHit work?
Well, what we see here in France is that typical manufacturer, wooden caisson manufacturer for the new build are moving to the retrofit, and this is the point where I think we'll have a lot of reduction in the price of the retrofits. Well, it's not a definite move, but there's much more money put on a retrofit nowadays than on a new build. And this is the reason why there's a big manufacturer from the new building side, which are moving to the retrofit side. And I think this is exactly where the turning point will be. Before, for a few years already, the retrofit was only done by special companies specified on retrofit, and this is what is changing nowadays.
Yeah, that's exciting. That's good.
Yes, here in Spain, we, for example, in retrofits, always are involved craftsmen and people with a low qualification, and that is always a problem, because if we want to improve these renovations and to improve costs and to improve times and everything, it's important to have to have all the participants in these projects must be qualified, And in this case, we find the qualification quite important to see our progress. Yeah, for example, here in Spain, now we have a lot of money for retrofits, energy retrofits from Europe, but we don't have enough people to do these retrofits, or qualified people, and then at the end we are always working in like handmade retrofits, and this is totally far away from what we want.
Yeah, that makes sense. Roman, did you want to add anything? Okay, so let's. How about speed? So, what was your experience of the speed of these projects and ways to both successes and then also ways to improve that speed?
Well, who wants to talk about speed? Everything is muted.
Yeah.
Speed depended a lot on the experience and the competence of the companies who actually offered the whole renovation concept or approach. So they started very ambitious and then were, let's say, slowed down by their own mistakes.
Yeah.
Well, yeah. On the one construction site, the landlord, the housing company, they pushed the contractor to bring some elements and to put it on the wall, and they did it. And afterwards, they realized that there were many some problems. Yeah, and so the thorough planning was just missing. And now you can ask who to blame for. I'm not sure, but the point is, in the beginning, you have to start thoroughly, and then if you have everything ready, then you can start to get faster. Yeah, but not the other way around, please.
Berthold's experience after the renovation of 7 or 8 buildings, it was, I guess, is do one sample project first.
Yeah.
Try things, test them, and if you know what you're doing, then do the other 6 or 8.
Yeah, and this is the advice for housing companies, not for the contractors. Well, they do what you say to them, but for the housing company, they themselves, should go for some experience and learn about it, and then they know who to ask for, and so on and so on.
Yes, I totally agree with Berthold. This is also what we did in this OutPHit project. We started with small buildings, about 300 to 500,000 square meters, and then we moved to bigger ones. Now we are moving to bigger buildings, such as the project in Saucy, which is 2,700 square meter, and I think now we have people talking about 11,000 square meters. So, well, we are moving from the small project with the certified buildings, and the proof that it works makes more interest in the range of bigger buildings. And I think this is exactly what has to be done. Start with small ones, and then when you're happy of a result you have on small ones, you go for bigger ones.
Yeah, and I think it's important that we don't underestimate the power of learning and learning curves. Yeah, I think that we see that all over the place in the clean energy transition, and I think that if there's anywhere in construction that learning rates could be a really significant driver of cost declines, it's when we're doing prefabrication. So Excellent. So to pivot a little bit, and one of the things I was really struck by, but the aesthetic quality of the retrofits, and so I wanted to ask, maybe start with Nuria, if you could share any advice or like things that you learned as you were grappling with both making this building in Madrid a high performance building, but also making it a compelling piece of architecture as well.
So what was our experience in this? What have we learned? Okay, yeah. That's a difficult question. So we started this building project, I think 4 or 5 years ago. So it's a long time to learn. And for us, it was quite important to do first a good quality project. So we have to study what we founded, the original building, and to develop all construction details, so to study and analyze every single detail of the building, and then when we started the construction works, we have to change everything, because you always, when you start to remove things, you find some things that you don't expect it at the beginning. So that was one of the things that I learned from this project, that in a retrofit, sometimes you have to not improvise. So, but you have to be open to the things that you will find during the construction works. But it is always not what you think at the beginning when you start the project first. And this is why I think it's very important to have a very qualified people working there in the design phase, but also in the construction site.
Fantastic, thank you. So I think we're a couple minutes over, but Ken gave me permission to just go a tiny bit longer, and I'd like to just close with a lightning round, and maybe let's do this in the order that you presented. So starting with Jan, and if you wouldn't mind sharing kind of like one top piece of advice for us here in the U.S. and in North America, if we were wanting to do an OutPHit, like what is the key piece of advice for us? And then we'll just go through everybody.
Good design, a good retrofit design. Design the approach well. That avoids the mistakes afterwards.
Thank you. How about you, Berthold?
And in addition, if you have this good design, if you have experience what you made once, you can repeat further and further and again and again. And this sentence comes, I got it from somebody from the US, but I forgot the name. I will see it afterward, but it's clear. Repeat it when you know it, what to do, repeat it once more. Well,
thank you. Nuria? Nuria, can you share your piece of advice for us?
My piece of advice is, I don't know what to say. So I think the best for you is to use your knowledge from the new building experience for the retrofits, and I think everything will come later easy.
Thank you. How about you, Etienne?
Well, I think it's important to think that we are just human beings, and human beings have all kinds of problems. Some of them have diffuse, and it causes a beautiful project to capsize. other disputes are with the neighbors. So it's very important you have a good relationship to the neighbors, because in one of the projects we studied in OutPHit, we had there was an argument with the neighbor who made the use of the external installation and impossible. So, well, keep in mind that we are just human. That's my advice for a good retrofit building success.
Some good overall wisdom as well. Thank you. And Roman, what's your advice for us?
I think we need to make more preparation with a retrofit project, like with the climate change, and we need to change with the climate. And the retrofit project, the first project, it was very difficult because there were not enough preparation. And now we need more and more preparation, because it is very important for people to manage a good system. So I think it's for tomorrow. It's important. So,
thank you, Roman. That's well said. Well, I think that wraps it up. I just want to say, Jan and Berthold and Nuria and Etienne and Roman, thank you so much for the work you're doing. You're on the vanguard, on this cutting edge of an incredibly important project for all of us and in the industry and you could argue humanity. So we appreciate what you're doing and this groundbreaking work and sharing it with all of us today. So thank you.